pa rin, Tatak City High.
Good day, everyone. Welcome to Science Class. Hi, I'm Teacher Christian, and I will be your guide in understanding the first concept for Science 8 first quarter. Are you ready? Alright, let's do this. Before we proceed, let's have the rules.
Rule number 1. Listen when someone is talking. And rule number 2, follow directions quickly.
Today's topic will revolve around the concepts concerning force and motion for Science 8 Module 1. And this will be the most essential learning competency for this lesson, which you'll be able to investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion.
And here are the subtasks. You have to identify and describe the types of forces, describe balanced and unbalanced forces, determine the net force acting on an object, and state Newton's first and second law of motion.
Alright, so I have here a figure showing you this ball on a table. Will this ball move by itself? How can we make this object move? And how can we make it change its direction? Okay, let's find out if you are correct. The answer is force. But what do we mean by force? In the lower grades, you learn that an object can be moved by pushing or pulling. In physics, this push and pull is referred to as the force. Force is a push or pull that can change the motion of all objects. Anytime you see something moving, you can be sure that a force created its motion. And here are the types of forces. First up, we have contact force. It is created between two touching objects. For example, holding a pencil, hugging someone, etc. The figure shows on your left side as an example of a contact force pointing the arrow to the right side, which the ground produces a contact force of the skater as she pushes against the ground. Next up, we have gravity, a force of attraction between two objects. For example, Earth's gravity. Looking at the figure, the long arrow pointing down makes the skater being pulled towards the ground. Next is friction. Friction is a force that resists motion between two surfaces that are pressed together. The figure shows the skater moving towards in that direction because the wheels and the ground resisting to each other when pressed. Looking back to this picture, do you think there is another force present to her?
What is holding the skater up? It's the ground. And that is the normal force. This is a support force exerted upon an object which is in contact with another stable object.
Forces have magnitude and direction, meaning it has size, which refers to the strength or the amount of force applied, and direction. For example, a smaller force of 5 Newton would have small, skinny arrow, and a larger force of 500 Newton would have either a long arrow or a thick. The unit for force is in Newton, or capital N. 1 Newton is equals to accelerating a 1 kilogram object at 1 meters per second each second. Usually, more than one force is exerted on an object at the same time. The sum of all forces acting on an object is called the net force.
Alright, so I have here another figure showing you the diagram of a pen in the book. What do you think pulls the book and the pen down? The force of gravity, right? What makes the pen and the book stay at rest? Are there forces present in them? Yes. For the pen we have tension force. In tension force, it is transmitted through a string, rope, cable, wire when it's pulled tight by forces acting from opposite ends. And for the book, it is called as the normal force. It is a support force exerted upon an object that is in contact with another stable object. Are the arrows of the pen and the book are equal? Yes. Since they are equal, are they balanced? Yes. And since they are balanced, do you think this is an example of the balanced force? Yes. Balanced force are forces acting on an object that are equal in magnitude and in opposite directions, and they lie along the same line of action. In balanced forces, the net force of an object is zero because there is no change in motion or the object is not moving. Okay, let's have some examples. Paper on desk, sitting on a chair, and a stationary flag.
Looking back to the example a while ago, a ball was on the table, and as discussed, we can say that this is an example of balance force. But what if I touch the ball and suddenly move? Do you think it is still balanced? No, because there is already a change on the ball. The sudden movement is caused by the unbalanced force.
In unbalanced forces, there is a net force acting on an object which causes changes in motion.
If the forces are moving in the same direction, add the forces. For example, if the forces are in the same direction, you add only their forces. In this case, their net force is 45 Newton. If the forces are moving in the opposite direction, subtract the forces. By this example, if the forces are in opposite direction, you only subtract the forces, and in this case, their net force is 2 Newton going to the right direction. Alright, let's try some problems.
Identify the net force of the following and you'll be given 10 seconds per item. And for the second item, and for the last item, okay, let's check your answers. Nice! I hope you got perfect score. Please do remind of the following key points. If two forces acting on an object are equal in magnitude but opposite in direction, they are considered as balanced forces. These forces must lie along the same line. If the forces acting on an object are balanced, the object stays at rest or continues to move at constant velocity. And if the forces acting on an object are unbalanced, the motion of the object will change. Alright, that's it for the first part of the lesson. Let's move on to the next. Before we proceed to the second part of the lesson, think about this. Why some objects remains at rest? And why some objects keeps on moving? Alright, as we proceed to the lesson, let us be informed to the man who brought this and proved certain things around us, and that is none other than Sir Isaac Newton, an English mathematician, physicist, astronomer, theologian, and author. Widely recognized as one of the most influential scientists of all time, and his famous laws of motion. Alright, let's start with the first law of motion, also known as the law of inertia. According to this law, an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. But you might wonder, what is inertia? Inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. For example, these pumpkins will not move unless acted upon by an unbalanced force. Now let's talk about mass and inertia. Mass is a measure of the inertia of an object. As you can see on the figure, the change in motion of the elephant was too little because of its mass compared to the man. Resistance of an object depends on the mass and inertia of an object. Let's have another example. This golf ball will stay forever on that position unless certain forces acted on it. This explains why some objects remain at rest in the absence of the outside forces. Alright, I hope that you already have an idea what this law talks about, and to further understand this law, Have you ever observed everyday objects in motion slowing down and becoming motionless seemingly without an outside force? It's a force we sometimes cannot see, and it's friction. And this is the reason why some objects in motion suddenly stops. There are four main types of friction. The first one, we have sliding friction, for example, ice skating. The second one will be rolling friction, for example, bowling. The third type is the fluid friction, for example, the air or water. And the last one, we have the static friction, which is the initial friction when moving an object. Because of inertia, objects including you resist changes in their motion. When the car going 80 kilometers per hour is stopped by the brick wall, your body keeps moving at 80 kilometers per hour. So this is important to always wear your seatbelts. We have the second law of motion, or the law of acceleration. According to this law, the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Simply says, the net force of an object is equal to the product of its mass and acceleration. Take a look at this video. On your left side, you see Newton applies less force to the rock, producing less movement or less acceleration. On your right side, you see the horse applies more force to the rock, producing more movement or more acceleration. Hence, force is proportional to acceleration. Let's have another video. On this video, you see the child easily pushed Newton because of his less mass, applying less force compared to the horse, which has more mass, applying more force. Therefore, force is directly proportional to the mass and acceleration. The change in motion depends on the mass of the object and the amount of force applied, which gives you acceleration is equals to force over mass. The amount of force depends on the mass times the acceleration, which gives you force is equals to mass times acceleration. And this will be the formula in order to solve for the mass. Alright, let's solve some problems. Alright, let's have item number 1. What do you think is being asked? Correct, it's acceleration. And these are the givens. What do you think will be the formula for acceleration? Very good. That is, acceleration is equals to force over mass. How about the solution? Very good. And we got the answer of 20 meters per second squared. this is for the second item. What do you think is being asked? Very good. It's the force. And these are the givens. How about the formula? Very good. And your solution, which gives us the answer of 90 kilograms times meters per second squared, or 90 newtons. Great job, students! Thank you for your participation. But please remind of the following key points before we end our lesson. Have you still remembered the first law of motion? Can you tell us about it? Very good. Law of inertia clearly suggests the more mass an object has, the more inertia it has, and the harder it is to change its motion. How about for the second law of motion? Can you tell us about it? Very good. Second law of motion tells us the net force of an object is equal to the product of its mass and acceleration. That's all for today. Thanks for listening.